Alright guys, so today we're going to be looking at Leetcode number 133, clone graph. So let's just jump right into it. So we're given a reference of a node in a connected undirected graph. So it's conveniently connected for us. We won't have any nodes that are disconnected. And what we want to do is we want to return a deep copy or a clone of this graph that we're given. So each node in the graph contains a value property and a list of its neighbors. So it's sort of giving you the class definition of our node here. And so if we look at the examples down here, we see that this is our original graph. And what we want to do is return a clone where all the nodes are the same, but we can't return the exact same graph. So I can't just return the node that we're given and be done with it. We have to actually go through the graph and clone each individual node. And similarly, we want to make sure that our graph is exactly the same as our original. We don't want to have any nodes out of place like we do in this example. So here we have 1, 3, 2, and the original is 1, 2, 3. So that's something we have to keep in mind as well. All right, so let's work through this problem and let's see how it breaks down. Okay, so how do we actually solve this problem? Well, there are two ways to do it. We have a depth-first search approach and we have a breadth-first search approach. I'm actually going to be talking about the breadth-first approach in this video just because I don't see too many other YouTubers talking about it. And so we're going to do that, and we're also going to need a hash map, just like many other graph problems out there. And this is going to be very important to creating our clone. So we're going to start with a queue data structure. If you're familiar with breadth-first search, and the first value in our queue is going to be our starting node. In this case, it happens to be 1, right? So 1 is going to be in the queue. And similarly, since 1 is our starting node, we can add it to the hash map right off the bat. And so the way we're going to store these items in the hash map is we're going to store the original node as the key, and we're going to store the cloned version of that node as the value, right? So that's going to be our sort of key value pair structure, right? We're going to have the old node here and the new node here. We're going to do that for every node that we come across. So we start off with 1 in our queue, and we shift it off of the queue and store it in a variable. So cur is going to be equal to 1, right? Because we just grabbed it off the queue. And now we want to loop through current neighbors. So if you remember from the class definition, the node has a neighbors list, so we can just loop through that. We can say something like for neighbor of cur.neighbors. So that's going to be 2 and 4. Let's say our first neighbor that we look at is 2, right? So first we're going to check, well, is 2 in the hash map yet? In this case, it's not. So we're going to store 2, and we're going to create a new node with the value 2. And that's going to be our value property in the map. And then we're going to add 2 to the queue. Okay, now if you imagine our graph is something like this, right? Our new graph that we're creating is like we have 1 here and we have 2 here, and they know nothing about each other. They're not connected at all yet, right? So we want to actually connect these two nodes as well. So after we add it to the hash map and after we add 2 to the queue, we want to actually connect 1 and 2 together. So we want to connect cur, which in this case is 1, to our node 2. So the way we can do that is we can just get cur from the map by saying map.get cur, and then we can get the neighbor by saying map.get neighbor, and that's going to give us our cloned version of each. And then we can just push 2 onto 1's neighbor list. So we'll have this one-way connection just like that. If you imagine it in like an adjacency list format, right? We would have 1 and 2. They both have no neighbors yet. And we just want to push 2 onto 1's neighbor list, and that's going to give us a one-way connection. Now, since we're dealing with an undirected graph, that means the connections will go both ways. So we want to make sure that 1 is also in 2's adjacency list, or 2's neighbor list. So We'll do that later. But for now, we can just point 1 to 2 just like that. Then we can look at one's other neighbor. In this case is 4. We add 4 to the hash map because it's not there yet. We create this clone of 4. So like 4 is just out here. And then 4 is also over here as well, has no neighbors yet. And then we also want to add 4 to the queue as well, like so, right? And so now we also want to connect 1 to 4. So similarly, we're just going to get the new 1 from the hash map. We're also going to get the new 4 from the hash map. And we're just going to push 4 onto 1's neighbor list. So you can imagine 1's neighbor list looking like this. It's going to have 2 and 4. So these are just one-way connections right now. And so now we're done. We've processed all of 1's neighbors, and we can basically reassign cur to be the next value in the queue. In this case, it's going to be 2, right? We're going to grab 2 from the queue, and that's going to be our new cur. Let me just make this blue to be consistent. And now we start the process over again, right? Now we want to look at 2's neighbors. So we're no longer looking at 1. We're at 2. I can actually maybe say like C. This is our cur. And so what are 2's neighbors? Well, 2 has a neighbor 1, and it also has a neighbor 3. So we've already been to 1, right? We know that because it's already in our hash map. We can check and we see, okay, 1's in our hash map. So we don't need to put it on the queue, and we don't need to add it to the hash map because we've already done that step. So all we need to do is just connect 2 and 1, right? So I can get the cloned version of 2 from the hash map, just like before. And then I can get the clone of 1 from the hash map by using the neighbor property. And I can just push 1 to 2's neighbor list like that. And now I have my two-way connection. And so now I've finished processing 1. So now I can look at 2's other neighbor, 3. And I can say, is 3 in the hash map yet? No, it's not. So let's create it. So 3, just like that. And now we can imagine 3 being here. I'm just going to move this up a bit. Just give myself a bit more room. I'm going to say 3 is here. It has no neighbors yet. So it's just kind of out here in the void. So we've added it to the hash map. Now we want to add it to the queue next. So our queue is going to look like this. We already have 4, and now we just push 3 onto it, right? And now we want to connect 2 and 3. So we could just do that. We grab the clone of 3 from the hash map, and we can grab the clone of 2 from the hash map, and just push 3 onto 2's neighbor list. So now it looks like this. All right, cool. So you can kind of see how this is taking shape, right? So now we've finished processing all of 2's neighbors, so let's look at 4's neighbors, right? So we grab 4 from the queue. So our cur becomes 4. And now our queue only has 3 in it. And now we say, okay, well, what are 4's neighbors, right? If we say now, this is our cur, well, 4 has 1 as a neighbor, and 4 has 3 as a neighbor. Okay, so let's look at that. Is 1 in our hash map? Yes, it is. So all we need to do is just connect 1 and 4. And so we'll just push 1 onto 4's neighbor list. And then similarly, we look at 3. 3 is already in the hash map. So we just want to push 3 onto 1's neighbor list. 3 onto 4's neighbor list. So we have this two-way connection here and this one-way connection here. Now we're done with 4's neighbors. So we can grab 3 from the queue now, and we do the same thing. So now our current value is 3, and 3 is connected to 2 and 4. So 2 is already in the hash map. So we just make that two-way connection by pushing 2 onto 3's neighbor list. And then similarly for 4 is already in the hash map. So we push 4 onto 3's neighbor list. And then we're done with cur, and our queue is empty. So we finish our iteration, and we're actually done. So now we have a fully constructed clone of our original graph, and it has the same connections. So all we'd want to return in this case is just this node right here. And that's it. That's how this algorithm works. So hopefully that made sense. And now I'm going to walk through the actual coding implementation and sort of work through the details, and hopefully you'll have a better understanding after that. All right, so let's see what this is actually going to look like in code. So first things first, I want to declare my queue like so, and that's going to have our first value, which is going to be the node that we get passed in. And I also want to declare my map as well. And I want to set the first key value pair in our map to be the node that we're passed in. And we're going to create a new node using the original node's value. And we're going to set its neighbor list to be an empty array. And now we're going to begin our loop. So we're going to say while our queue has a length, we're going to grab the current node on the queue by using queue.shift, just like we said. And now we want to loop through cur's neighbors. So the way we do that is we just say for neighbor of cur.neighbors. And so now for each neighbor, we just want to check if the neighbor is in the hash map. The way we do that is we just say map.has neighbor. And so if the map does not have the neighbor, then we want to set it. So just like we did on line 17, we're just going to say the key is going to be the original node. In this case, it's neighbor, and the val is going to be a new node with neighbor.val and an empty neighbors list, right? So hopefully that makes sense. So the second thing, we also want to add the neighbor to the queue. So we can just say queue.push neighbor. And that's all we want for this if condition. So the last thing we need to do, just like we talked about in the conceptual overview, is we want to actually connect the current node to the neighbor that we're currently looking at, right? So how do we do that? Well, like I mentioned, we can declare two new variables. I can say clone node is equal to map.getCur, right? So this is going to get our clone version of cur, right? Because remember, the key is the node and the value is the clone. So we're going to get the clone node, and we're also going to get the clone neighbor by using map.getNeighbor. So this is going to get our clone neighbor. And all we need to do is we just say clone node.neighbors.push clone neighbor. And so that's going to create that one-way connection that we talked about from one node to the next, right? And so that's actually everything for the while loop. So we can actually go down here and we just want to say return map.getNode. So we just want to return the clone version of the original node, right? And that is everything for this algorithm. So this is going to run in O of n plus m time complexity because we are traversing every single node. And then similarly, our space complexity is going to be O of n because we are storing each node in the queue as well as in the map. And so n is going to represent the number of nodes. M is going to represent the number of edges, right? Because we can have more connections than we do nodes. So we have to take that into consideration. But in terms of storage, we're only ever storing the nodes themselves. So that's it for the breadth first search approach. Let's just see if this works. Oh, looks like I have a small error here. Yeah, so we do need to handle an edge case if we're given an input of nothing. So we can just say if there is no node, let's just return null. So that's our only edge case. And there we go, that works. All right, so I hope this was helpful, and I will catch you in the next video.